Okay, now the particle theory of matter. Now it's recording. If it's recording. The particle theory of matter says solid changes to liquid, liquid changes to gas. What the timer here? When it's 9 minutes, let me know.
Okay.
When it's not, set the timer now. 9 minutes.
9 minutes?
9 minutes.
Okay.
Okay. Now, solid, liquid, and gas. When a solid changes to liquid, we call that what? We call it melting. We say it melts, isn't it?
Yes.
Now, when the liquid converts to gas, we say that it's boiled,
Or evaporation.
boiling, or evaporation. Boiling or evaporation. And the other way around, we can have it coming back to this side. When the gas changes to liquid, we say condensation. And when the liquid converts to solid, we say it freezes. This is freezing. So you must be able to know these things well. Know when solid changes to liquid, it melts. And the reason it melts, I told you this before. Here, the force of attraction is strong. The forces of attraction between the particles is so strong. Now, when you apply thermal energy, let's say you apply heat, it's gonna make the particles to vibrate faster, and again break away from the force of attraction, which was holding them together before, and now they become what? They become a liquid. That's called melting. If you continue to heat it more, or you continue to put it in an environment that is warm, it starts more thermal energy, and that's when it evaporates or boils. And I told you the difference between boiling and evaporation is that boiling occurs what? Throughout the particle. Throughout the particles in the container at the same time. It occurs throughout the particles of the what? Of the container at the same time. At what? At the same time. And why evaporation occurs in stages? It occurs in what? In stages. It doesn't occur at the same time. The point I'm making is when you're boiling water, the water will keep boiling, all the particles will move faster, and they start to leave the container. But the case of evaporation is when you leave it outside, some particles which will gain more energy stronger than the force of attraction between the particles, those ones will leave first. They will leave the remaining ones inside the container to be able to gain the same energy stronger than the force of attraction before those ones too can be made to leave the container. Otherwise, they will remain in that container because the force of attraction between the particles is not broken yet. Is that okay? May I know what you're roaming about now? Go back to your place. Go back to your place. Now, what are you saying?
This is what in evaporation and just in cooking, or you can make cook or make tea from evaporation. Yes.
You can make tea.
No, and you can make something inside. Like if you want hot water.
Yeah, you cannot heat water with evaporation. Because boiling point has a point where it boils, but we don't have a point for evaporation to occur. It occurs at all temperatures, and this occurs at it has a fixed temperature where it occurs. While this occurs at all temperatures. It occurs at any temperature when we talk about it's occurring. So that's the reason we call it what? Evaporation. It called the other one boiling. And now when the gas try to convert to be liquid.
Mr. In the evaporation,
Yeah.
it evaporates faster when
It's boiling.
Yeah, boil.
If it's boiling, the particles are moving faster and they leave in the container faster. And that's the reason we say it's boiling. But in the case of evaporation, it's not fast. It's not the way it is in boiling. And that condensation occurs when you have the particles having enough space between them, because they've been able to gain enough energy to overcome the forces of attraction between them. And now when you try to condense it, that means the strong forces of attraction will not be able to start to put together again. when the forces become small, they start to get the particles joined together because the particles are losing energy. And the reason they're losing energy is because the thermal energy is being sent to the environment, and now they're losing the energy. When they're losing the energy, they become more compacted again, and the forces of attraction become stronger, and that's what we call condensation. Condensation occurs when the gas converts to be what? To be a liquid. And also, the same process becomes more pronounced when liquid converts to what? To solid. The liquid only converts to be solid when the strong forces of attraction between the particles is now becoming greater. And that's the reason the particles will now arrange themselves again in a regular pattern and form the solid. Don't forget about the arrangement of the particles. I told you that in the case of a solid, the particles are arranged in a regular pattern. It has a regular pattern arrangement. They are arranged in this kind of form, because the particles are they're tightly packed together. But in the case of the case of liquid, the particles are they're sliding past each other, and that's the reason why the particles are called this liquid, because they can move freely. So now in this case, they're tightly packed together by strong forces of attraction. But in the case of liquid, the particles are arranged but not in a regular pattern. They are sliding against the wall past each other. But in the case of a gas, they are far away because of what? Because they don't have enough force of attraction between them, so they could be anywhere. They could be outside the container. Yeah.
But in liquids, you touch each other.
They slide past each other.
And you don't touch each other in normal?
No,
They slide. When they slide past each other, they touch it, isn't it? But something slide past you, touches you. Is that okay? But here you say they're tightly packed together by strong forces of attraction. Is that okay? Now let's talk about. Are you checking the time?
Yes.
Now let's talk about compressing.
6 minutes.
That's still recording.
Yeah, Mr. That's why all of your videos are 10 minutes on your YouTube.
Yeah. Now when you talk about compressing solid, liquid, and gases, we can only compress gas. The reason we can compress gas is because we have enough space between the particles. So when you try to compress it, when you try to apply force on the container, you can reduce the space between the particles and make it smaller in size. That's the reason we can only compress gases. But liquids are not compressible. The reason is because the particles are already touching each other. And as I was saying before, if the particles touch each other, they slide past each other in this kind of manner. And that's the reason we call it a liquid. But the case of solid, the particles are tightly packed together. They're not made to, or they're not even free away from each other at all. So because the force of attraction is so strong, and that's the reason we call them solid. So they're not compressible. Only the gases are compressed. Someone told me before, he said the water are compressible. I said no. If you put the water in the container, you're trying to apply force on it. It will break it. Because that water will not what? The water will never become smaller. And I told you that the reason why particles compress is not that the particles are getting smaller, but the spaces between the particles are getting reduced. The space between one particle and the other one is getting reduced, and that's the reason it's contracting. Now the particles are getting smaller. I keep repeating this to you. If you're writing your exam, the particles are smaller, you get it wrong. Tell me the space between the particles are getting reduced, and that's the reason they become what? They become smaller. I said there's a difference between when you tell me the particles are reducing. Particles don't get bigger, and particles don't get smaller. Only that the space between them increases or decreases. Is that okay? The space between the particles can either increase or decrease. And when the space between the particles increases, we say it expands. We say what? We say it expands.
Like it's
It's time?
Yeah, 9.45 seconds.
Okay, we say it expands when the space between the particles are bigger. Oh, it's expand, but when the spaces between the particles are smaller, we say it contracts. So contraction occurs when the particles get closer to each other. Where it expands when the particles get farther away from they get farther away from each other. Now, the next page we'll talk about boiling.